Inner classes are non-static classes declared on an enclosing class at the member level. Inner classes can have any of the 4 valid access modifiers: public, private, protected, or have no modifier at all, which makes them packaged private. An inner class has access to instance members, including private members of the enclosing class. Instantiating an inner class from external code is a bit tricky. I'll cover that shortly. As of JDK 16, static members of all types are supported on inner classes. In the previous video, we looked at static nested classes with a comparator class example. I want to do something similar here to look at inner classes and how they differ from static nested classes. The first thing I'll do is create a new class called storeEmployee in the dev.lpa.domain package. I'll have it extend the employee class that I created in the last video. I want to add a field to this class called store. Next, I'll add an inner class and call it storeComparator. I do this by declaring a class inside the store employee classes opening and closing curly braces. I'll have that implement comparator with a type argument of storeEmployee. I'll add the class and add a diamond operator with T extends storeEmployee within. Then I'll implement comparator with storeEmployee in the diamond operator. IntelliJ tells me I need to implement a compare method, so I'll do that. I want to change the code in this method to first compare the store field. Int result equals o1.store.compare to o2.store. Return it. If the result is 0, that means the employees work at the same store, so I want to add another comparison level. This time I'll call the employee.employee comparator constructor, passing it the year started, and using that compare method. Check if employees are at same store. If yes, then return a compare of year started for both stores. This gives us a sort by store, then year started within the same store. I also want 2 constructors on this class. I'll be using the first a noargs constructor to access this comparator from the calling code. I'll generate that now. I'll also generate a 4-argument constructor that will call supers constructor and then assign the store argument to the store field. Finally, I want the store to print out each employee. To do this, I'll override the toString method. I'll change the generated code. The new code will return a formatted string that has the store and also the string representation of a regular employee. It's time to go back to the main method. Remember that the employee comparator is a static class on employee, and I can create an instance of it by accessing it through the enclosing class name, as you see here on line 22. I simply instantiate that comparator by saying new employee.employee comparator with the diamond operator. This isn't true though for non-static nested classes or inner classes. First, I'll print out a heading. I'll create a list of store employees in much the same way I did the employees. The list will be called store employees, and I'll use an array list and initialize it using list.of and passing a number of new store employee instances. First employee Meg, year 2019 and store is Target. Next Joe, year 2021 and Walmart. Tom with year 2020 is next. He works at Macy's. Marty, year 2018 and Walmart is next. And the last one, Bud, year 2016 and Target. I'll add the for loop to print each store employee. Before that loop, I want to add the call to my store employee comparator, but how do I call it? Let me set it up like I did before using the employee comparator on my new store employee class. var comparator equals new storeEmployee.employee comparator. Call storeEmployees.sort, passing comparator. This code compiles and I'll run it. And yes, it sorts the store members by the default sort for that comparator, which is name. But in this code, I'm not using the store comparator I created on store employee. Instead, I'm using the static employee comparator on employee, and you can see that if you hover over that local variable comparator, this means I've accessed the comparator on employee through the store employee class. This means that static nested classes are inherited by subclasses. But that's not really what I want to do here. I really want an instance of store employee's own comparator class, an inner class which I called store comparator. What happens if I just replace employee comparator with store comparator in my local variable assignment? Let me try that out. Now I've got a problem. If I hover over that, I get the message that store employee is not an enclosing class. That's because an inner class requires an instance of the enclosing class to be used in order to instantiate an inner class. Here, I'm really calling the class store employee and not an actual instance of the store employee class, so it doesn't work. To get around this, I'll create a new variable and assign it a new store employee instance using my noArguments constructor. I'll then replace store employee on the next statement with my local variable generic employee. But that doesn't work either. I do get a different error message though. Cannot resolve symbol store comparator. To create a new instance of the inner class, we have to use a special syntax on our outer class instance .new. I want to remove the new keyword before generic employee and then append .new to generic employee. But I don't pass anything to .new because it's not a method. Instead, I include a space after it and then I have the inner class construction code. The compile error has disappeared, so I'll run this now. As you can see, my store employees are sorted by store first, then year started, which is how I implemented the store comparator's compare method. So that's good. If I didn't want to use a local variable, I can chain the instantiations. Let me show you that. First, I'll remove that local variable generic employee. Then I'll change the next line, and instead of generic employee there, I'll replace that with new store employee. In either case, I am first instantiating an instance of store employee. Then I have to call what looks like at first glance a new method, but it doesn't have parentheses associated with it. This .new syntax isn't calling a method, but rather it is creating an instance of an inner class which I've declared on store employee. To create an instance of an inner class, you first need to have an instance of the enclosing class. From that instance you call .new, followed by the inner class name and the parentheses, taking any constructor arguments. This definitely looks strange the first time you see it. Many times an inner class is never accessed or instantiated from outside the enclosing class, but you should still be familiar with this syntax. Okay, so I've used both a nested class and an inner class to implement a comparator for a couple of business classes. Let's take a small break from the comparator examples. I'll circle back to more of these for our other two nested classes later. For now, I want to show you how to use an inner class to re-implement part of the Bill's Burger code that was part of a challenge in an earlier section. I'll do this in the next video, so I'll see you there.